This video covers solving equations with half-angle formulas, and our problem that we are going to be solving is the sine of x over 2 plus cosine of x minus 1 is equal to 0. So if we take a look, this is our half-angle right here, and we can start off by substituting that for 1 minus cosine of x over 2, and this is positive or negative. And our next step is going to be to move everything to the other side. So since it's plus cosine of x minus 1 is equal to 0, we are going to subtract cosine of x and add 1. So when we do this, we will get square root of 1 minus cosine of x over 2 is equal to 1 minus cosine of x. So the next thing we are going to do is square both sides. And when we square both sides, the square root on this side will cancel. So we are going to be left with 1 minus cosine of x over 2. And this would be squared. And when we FOIL this out, we get 1 minus 2 cosine of x plus cosine squared x. So now what we're going to do is multiply by 2 to get rid of the denominator on the left side. So when we do this, that cancels, and we are left with 1 minus cosine of x. And when we multiply by 2 on the right side, we get 2 is equal to 2 minus 4, minus 4 cosine of x plus 2 cosine squared x. So now what we are going to do is get everything to the same side. So to do this, we will add cosine of x and subtract 1. So we get 2 minus 4 cosine of x plus 2 cosine squared x minus 1 plus cosine of x. So if we take a look, we have like terms here. We have 2 minus 1, which will reduce down to 1. And we have negative 4 cosine of x, and we have a positive cosine of x, so that will reduce down to negative 3 cosine of x, and we still have 2 cosine squared x. So now what we do, if we could just rewrite this. So now if we take a look, this is basically the same as having 2x squared minus 3x plus 1. And when we factor that out, we get we get 2x minus 1, and then we get x minus 1. So basically x is equal to cosine. So when we substitute this back in, we have 2 cosine of x minus 1 times cosine of x minus 1. So using the zero product property, we can separate this. So that would be equal to 0. And if we add 1, we get 2 cosine of x is equal to 1 divided by 2. Basically, we get cosine of x is equal to 1/2. And if we do it for the right side, we get cosine of x is equal to 1. So now what we have to do is figure out where cosine of x equals 1/2 and where cosine of x equals 1 on the unit circle. So if we look at our unit circle, cosine of x equals 1/2 at the 60 degrees, and at 300 degrees, and cosine of x equals 1 at 0 degrees. And if we want to write 60 degrees in radians, it's pi over 3, and 300 degrees is 5 pi over 3. So now that we have our solutions, we have to check for extraneous solutions because we squared both sides. And when we square both sides, we may create solutions that may not actually be solutions. So to check, we are going to plug our values into our original equation, which is sine of x over 2 plus cosine of x minus 1 is equal to 0. So we're going to plug in our values that we want to check. So if we were going to check for the 60 degrees, sine of x over 2, basically x is equal to 60 degrees, so sine of x over 2 would be sine of 30 degrees plus cosine of 60 degrees minus 1 is equal to 0. So if we look at our unit circle, the sine of 30 is 1/2 plus the cosine of 60 degrees, which is also 1/2, minus 1 is equal to 0. So 1/2 plus 1/2 is 1, 1 minus 1 is equal to 0, so that checks, that is an answer. Now if we are going to be checking 300 degrees, x is equal to 300, so sine of x over 2 is equal to sine of 150 plus the cosine of 300 minus 1 is equal to 0. So if we look at our unit circle, the sine of 150 is equal to 1/2. The cosine of 300, which is also 1/2, minus 1 is equal to 0. 1/2 plus 1/2 is equal to 1. 1 minus 1 is equal to 0. So that checks, it is an answer. And now we're going to be checking 0 degrees, so sine of x is equal to 0, sine of x over 2 is still 0, so sine of 0 plus cosine of 0 minus 1 is equal to 0. So sine of 0 is equal to 0, cosine of 0 is equal to 1, and minus 1 is equal, so 1 minus 1 is equal to 0, 0 equals 0, so this checks. And that is how we solve equations with half-angle formulas.